You are given number of courses, prerequisite pairs, and query pairs. Pair A, B means course A must be taken before course B. For each query U, V, answer whether U is a direct or indirect prerequisite of V. Example 1. Pair 1, 0 means 1 is a prerequisite of 0. So query 0 to 1 is false, and query 1 to 0 is true. Example 2. With no prerequisite edges, neither course depends on the other, so both queries are false. Think of each query as a path check in the prerequisite graph. Query 1 to 0 is true because a path exists, 1 to 2 to 0. Query 0 to 1 is false because there is no directed path from 0 back to 1. With many queries, pre-compute reachability once in a Boolean table. Then each query is a constant time table lookup. Approach in plain steps. Since queries can be many, we pre-compute reachability once. Use two phases. First, build the full reachability table, starting from direct edges and filling indirect paths. Then answer each query with a single table lookup. The single data structure is a Boolean matrix. Cell U, V tells whether course U is a prerequisite path to course V. Think of I and j as row and column names in the table. For example, cell 1, 0 asks whether course 1 can reach course 0. Step 2 only walks the prerequisite list to mark direct edges. After that, filling indirect paths does not use the prerequisite list anymore. You run 3 nested loops with k on the outside, then I, then j, each ranging over every course index. Picture filling indirect paths as 3 nested for loops. K is the outer loop, I is the middle loop, j is the inner loop. Each runs from 0 through n-1. Inside the innermost body, if I can reach k and k can reach j, mark I can reach j. Step 1. Start with a false table of size n by n. Step 2. Mark direct prerequisite edges as true. Step 3. Fill indirect paths with nested k, then I, then j, each index from 0 to n-1. Step 4. Now every query is a direct table lookup at reach UV. Because k, I, and j each run n times, you get on the order of n cubed inner updates in the worst case. The upside is every query becomes a single table lookup. Solution walkthrough on 3 courses. Prerequisites 1, 2 and 2, 0 form a chain 1 to 2 to 0. We use the same query list as before so you can read answers straight from the reach table. Filling indirect paths uses 3 nested loops. K is the outer index, then I, then j. For 3 courses each runs 0, 1, 2. So for each fixed k you still evaluate 9 ij pairs in the inner 2 loops. Only some pairs will actually flip a cell from false to true. Start from an all-false reach table. Row U column V will store whether you can reach V in the prerequisite graph. Mark direct prerequisite edges. 1 reaches 2, and 2 reaches 0. So reach 1, 2 and reach 2, 0 become true. Outer k is 0. The inner I loop and inner j loop still visit all 9 ij pairs. None of those checks finds both reach ik and reach kj true in a way that creates a new true cell, so the matrix stays the same. Outer k is 1. The inner I loop and inner j loop still visit all 9 ij pairs. None of those checks finds both reach ik and reach kj true in a way that creates a new true cell, so the matrix stays the same. Outer k is 2. Among the 9 ij pairs, this pass newly sets row 1 column 0 to true, because reach 1 2 and reach 2 0 are already true. Preprocessing is done. Now each query is one Boolean lookup in this table. Query 1, 0. Read cell row 1 column 0. That is true. Query 1, 2. Read cell row 1 column 2. That is true. Query 2, 1. Read cell row 2 column 1. That is false. Query 0, 1. Read cell row 0 column 1. That is false. Collecting the 4 lookups gives true, true, false, false. Complexity. Time is order n cubed plus q, filling the reach table uses 3 nested loops over n, and each of the q queries is a constant time lookup. Space is order n squared for the Boolean matrix. The cubic term is the dominant preprocessing cost. Function check if prerequisite. Allocate an n by n reach table initialized to false. Loop over each prerequisite pair a, b. Mark the direct edge reach AB as true. Outer loop, k from 0 to n-1. Middle loop, I from 0 to n-1. Inner loop, j from 0 to n-1. If I can reach k and k can reach j, then mark I can reach j. Build an empty answer list. Loop over each query u, v. Append reach uv to answers. Return answers.